Hello everyone, welcome back. Uh, in today's video, we will talk about the change. And as we all know that change is the only constant, so we will see how change happens in mathematics and what are the properties which are retained in any change, what properties are changed in a change, so all those things. Now, before we move on, please recall a process that changes the position, shape, or size of an object is called a transformation. For example, you have your beautiful calculator. Maybe it can move to the right or it can move to the left. So this is also a transformation. Or maybe it can enlarge, it can diminish. This is also a change. It can turn again in other direction. So all these things are changes or transformations. We call them transformations. In a transformation, position, shape, or size of an object may change. Right? Now, how does it look like in a maths class? So let's observe it in a mathematics class. So let's say you have a curve. It is a simple quadratic curve. Maybe this curve can move onto the right hand side. Now, when it moves to right hand side, you see its shape is same, but the equation has changed. So when an object transforms in mathematics, its equation changes. Or if we change the equation, we can say the shape will transform. Or maybe if you flip it around, or maybe if you compress it, let's say it is compressed, again it is a transformation, so its equation will change. Or if it is reflected, its equation will change. So today we will see how these transformations occur, how an object undergoes any like transformation or a series of transformations, and what is its impact on the original equation of the graph. Since you have already covered transformations, so I would like you to quickly recall different transformations. First one is translation. A translation may happen in two ways, either a horizontal translation or a vertical translation. In a horizontal translation, object moves either to the left or to the right. So let's say y is equal to fx is a function. If you make any change to the equation of this function, then you will observe some transformation. So when the function fx becomes fx plus a, where we are assuming a is a real number more than 0, that is a positive real number. In this case, your graph will slide or translate to the left hand side by a units. We can represent this using this translation matrix, that is negative a comma negative a 0. If fx becomes fx minus a, then your graph will translate to the right hand side by a units, provided a is a positive real number. This can be represented by this translation matrix, which is a0. Right? So either you have vertical or horizontal. Now if you observe here one thing, when a change is made to the x value, x means the horizontal, then there will be a horizontal movement. Now if the entire function is added, let's say fx is a function, and if entire function is increased by a constant, a positive constant, so now changes are made to the y, so you will see a translation along y. So if you add with a positive number, it moves up, so the graph will slide up by a units, and we can write it as 0a in a matrix form. And if it is fx minus a, again the change is happening in the y component. When it is fx minus a, your graph will slide down by a units, and we can express it as 0 negative a because it is sliding down. So these are translations. Other type of transformation is reflection or a flip. So when the sign changes, x becomes negative x or y becomes negative y, you will observe transformation, which is reflection. So let's say y is equal to fx is a function. if fx becomes f of negative x, when x becomes negative x, then you will see that a reflection occurs in the y-axis. And when uh, the function becomes negative of fx, entire function has been made negative here, this will be a reflection in the x-axis. The next transformation that I would like you to recall is dilation. What is dilation? In dilation, either there is a compression or there is an expansion, either vertically or horizontally. So if y is equal to fx as a function, if you multiply either x value or y value with a constant, then you will observe a dilation. How it happens here? When y becomes a times fx, means entire function is multiplied with a, or say y value is when multiplied by a, you will see a vertical expansion when a is more than 0. Remember, we are assuming that a is always positive. So when a is more than 0, there will be a vertical expansion, and when a is between 0 and 1, there will be a vertical compression. And when x is multiplied with only the x value, you will see horizontal compression or expression. Please note, when a is more than 0 in case of vertical, there is expansion, but in case of a horizontal, it will be a compression. So you will observe a horizontal compression when a is more than 1, and a horizontal expansion when a is between 0 and 1. I would like to mention here, there are certain points which do not change in any translation, or reflection, rotation, dilation, or we can say there are certain points which remain constant during any transformation. Those are called invariant points. So what are invariant points? Invariant points will lie on object and image both, right? Now, how do we use these transformations to change a function or sketch a function? This is a very popular kind of type of questions in IB, Diploma, SL and HL both, paper 1 and usually paper 1 exam. You will be given a function and you will be asked, identify all the transformations and which map the original function to a given function, then sketch it. Remember one more thing. All linear functions, if you have a linear function, any linear function, then all linear functions are basically transformed from y is equal to x. So y is equal to x is your mother function here. All quadratic functions are transformed from y is equal to x squared. So y is equal to x squared will be your mother function here. Similarly, for different types of functions, there is always a mother function. Okay, have a look at this example here. Without using technology, appropriately label and mark all axial intercepts and sketch the graph of the function fx is equal to negative x squared plus 4x minus 3. Now, out here, sorry, the first thing, it is a quadratic function, means it was y is equal to x squared at some time. From y is equal to x squared, it has been transformed to this function. So to sketch it without calculator, what do we need to do? You just have to identify all the transformations that y is equal to x squared has been through, and then sketch it. So how do we do this? Number one, let's start. So in y is equal to x squared, there is only one term in x. Out here we have two terms in x. So we have to combine these two. And the best way to do this is to complete the square. So when you complete the square, fx is equal to negative x squared plus 4x minus 3. So to complete the square, we first take negative common. You get negative of x squared minus 4x plus 3. Now merge these two terms, so it becomes x minus 2 squared minus square of 2, that is 4, plus 3 as it is. When simplified, this will be your form. So when you complete the square, this is what you get. Now, second step is identify all the transformations that map y is equal to x squared onto this one. So let's start. So initially when it was y is equal to fx is equal to x squared, second step would be x minus 2 squared. The third step will be a negative comes here in front. So negative of x minus 2 squared, and the next step will be plus 1. So just add 1 here. So you get x minus negative x minus 2 squared plus 1. Now, how it looks on a graph. So when we sketch, we'll sketch in these steps. First, y is equal to x squared, then x minus 2 squared. When you have x minus 2 squared, there will be a translation to the right hand side. Then negative comes, so it will be a reflection in the x-axis. Plus 1 means it will translate. So let's see how it happens. So let's get a graph paper here. Y is equal to x squared will be a curve like this passing through 0, 0. So let's sketch the curve. Y is equal to x squared. When we say sketch, it doesn't need to be point to the scale. Sketch means appropriate shape with appropriate points marked. Then x minus 2 square will move this graph to the right hand side by 2 units. So let's move it. So it moves by 2 units. Then third is negative. So it will be reflected in the x-axis. So let's reflect it in the x-axis. So this is how it is reflected. We don't need that upper graph, so just get rid of it. The next step is plus 1. So this graph has to move up by 2 units. So let's move it up slowly. So it moves up by 1 unit. So it moved up by 1 unit. So this is your final graph. So you can bold this graph. Now we have to mark axial intercepts and all important points. So first important point is this vertex. So it was at 0, 0, it moved to 2, 0, then it went up. So this point is going to be 2, 1. Now x-intercepts. So x-intercepts are basically zeros of this polynomial. It means when you solve this as quadratic equation, whatever you get will be your x-intercept. So let's solve this equation. Negative x squared plus 4x minus 3 is 0. When you solve, you get x is equal to 1 and 3. So your first x-intercept will be 1, 0. Second will be 3, 0. For y-intercept, at y-axis, x is equal to 0. So when x is equal to 0, this is 0, this is 0, this is negative 3. So y will be negative 3. So x is equal to 0 at y-axis. So y-intercept will be 0, negative 3. So you can mark your y-intercept here. So that's how you use different transformations to sketch a curve without using a calculator. I hope this explanation was helpful. If you found this video helpful, please consider subscribing it, like, subscribe, share, and don't forget to press the bell icon so that you're the first person to get the notification when a new video is posted. Take very good care until we meet again.